are now going to go on to looking at 3D shapes and their surface area. Okay, so what is the surface area? The surface area is the area of their faces, all summed together. This area of faces. So just to give you a visual of that, I have made a little cone. I have made a little cube. So here is my cube, and if I wanted to calculate the surface area of the cube, that is the sum of the area of the faces, and if we were going to unwrap the cube, that would look like this. So the surface area is all of this here, so if it's been wrapped up. So that would be surface area of a cube. There are some other surface area equations that you might need to know. So for example, if we have a sphere, I don't know if you're trying to imagine unwrapping that, but I don't think it doesn't really make much sense. So what you need to know for a sphere is the surface area of a sphere is 4 pi r squared. There we go. Let me get my can of baked beans. So we want the surface area of a cylinder, which is 2 pi r h plus 2 pi r squared. And I'll show you why this one makes sense in a minute. In fact, I'll do it now, but I'm going to have to rub out my shapes. So we know the surface area is the sum of the area of the faces. So if we have this cylinder here, so we have a cylinder, if I was to unwrap that, it would look a bit like this. I would have the face at the top, face at the bottom, and then this bit here. And we can see this formula is correct because this 2 pi r squared, that's the area of this one is pi r squared, because it's a circle, pi r squared, and there's 2 of them, so that's where this bit comes from. And then this bit here, this line here, wraps around when you put it back is this line here, so it's the circumference of the circle, and then this, so that is the, this length is the circumference, and that's 2 pi r from the formula we know, and then this bit here is h, that would be this bit there. So that's how we can see how that one works. There's another one we need to know, and that's the area of a cone, surface area of a cone. I had a mare trying to look for cones around the house and I couldn't, so we're just going to have to write this one down. So here we have our ice cream cone / cone, and the surface area formula for this is, not that, pi r l, and this here, that is L, plus pi r squared. So as you can see, that pi r squared is that bottom circle bit of the cone, and this pi r l is the part that wraps around. So let's do an example. This is an exam example. So let's make that clear. Sorry, chucking pens everywhere. Exam. I love it when my yellow pen is mixed with red, black. It's great. Okay, exam example. I'm gonna have to draw a shape again. Triangle. Do 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 do. Do do do. Okay, it wants the surface area of this shape here, and it gives you that this is 3 centimeters. This is a right angle. This is 4 centimeters. This is 7 centimeters. And this is 3 centimeters. Obviously not to scale there. So what we've got to think, what I like to do is I like to quite visualise what I actually need to break down. So I want the area of each face. So I'm going to draw each face out so I don't miss a face. So I've got this face here, the front face. I've also got the same back there. Yeah, that's another face. I've also got the bottom, this bit here, bottom. I've also got the back, that bit there, and I've also got this slopey, slanty bit. So I need to sum up the area of each of those. No, I know I haven't missed one. So, area of this triangle is half times base times height, half times 4 times 3, because that's 4 and that's 3, and that is half times 12 is 6. This one we know is the same, 6. These are centimetre squares. This here was the bottom bit, so we got that bit is 7 and that bit is 4, and we know that is 7 multiplied by 4, which is 28 centimetres squared. This bit here was the back bit, you can't really tell, and that is 3 there, and then that length there is the same here, that's 7, so that's 3 multiplied by 7, which is 21 centimetres squared. And we have this slanty bit here, and that is 3, that bit's 3, and that bit's 7, so again 3 times 7, 21 centimetres squared. Okay, so we have the area of each face, and now the surface area is the area of the faces, so we need to sum them all up. So we have 6 plus 6 plus 28 plus 21 plus 21, so 6 plus 6 plus 8 plus 1 plus 1 is 22, 2, 4, 6, 8, 82 centimetres squared for that one. I'm now going to take my sphere and I'm going to cut it in about half. Okay, we know that the formula for surface area of a sphere is 4 pi r squared, which I'm going to write here to remember it. And now I'm going to try and draw a hemisphere. That's kind of there we go. And I'm going to say that this distance here across is, let me get rid of the juice. I'm going to say that distance there is 8 centimetres. And you can think of this as a hemisphere, so half a sphere, this is a hemisphere. And I want the surface area of my hemisphere. So, I know that a hemisphere is half a sphere. I know that the formula for a surface area of a sphere is 4 pi r squared. So I'm now going to plug that in. A half times 4 times pi times radius, so careful, that's given the diameter, so we want half of it, so this here, the radius, is 4 centimetres, 4 squared. Okay, so that is, let's work that out, half times 4 times 16 times pi, that is 32 pi centimetres squared. We are not done, however, because we've got the 32 pi centimetres squared, which is half the sphere surface area. So we've got this bit, half of the curved bit, but we also need this bottom bit here. So we have this bit. Now we need the area of the circle base, and we know area of a circle is pi r squared, and we know that was 8 centimetres. That's the diameter, so we need the radius, which is half the diameter, 4 centimetres squared, so in our formula pi times radius squared, which is 16 pi centimetres squared. And now to get the total surface area, we sum up this part and this part, so we have 32 plus 16, which is 48 centimetres squared for the surface area, SA or South Africa, and that's how you would get the surface area of a hemisphere.